Your billing queue doesn't just reject claims, sometimes it quietly learns from your denials, and the moment prior authorization is denied, something unexpected can boost your next payment odds. In this video, you'll see how a reward prediction error flips the signal inside the system, turning no into a measurable advantage that keeps paying you back until it doesn't. Reward prediction error is what turns a maybe the next request works into a mental habit, and prior authorization denials exploit that habit inside billing queues. You can feel it in your own life when a phone app keeps flashing until one refresh finally succeeds. Schultz, Dayan, and Montague used dopamine neurons to show this learning signal when outcomes beat expectation. Dopamine activity spikes when outcomes fall short. It dips. That spike or dip is the brain's way of updating what it thinks will happen next, even when the pattern is noisy. In billing, the same update happens on a different device. A denial is supposed to end a path, but the system often sends you to a new path instead, like swapping channels after the show fails to load. Each micro try creates a newer prediction versus outcome moment. That moment keeps attention tethered to the Michael Lipsky's A Street-Level Bureaucracy describes a basic pressure when workers face heavy caseloads and tight rule constraints. Discretion grows where rules cannot fully control the day. Notice how in a hospital hallway, a receptionist handles the same person with the same form, yet still improvises the room. In Lipsky's model, frontline choices are shaped by what the system rewards, not by what the policy says should happen. When approvals are scarce and paperwork is endless, workers learn to aim for the next feasible outcome. Billing teams act like that street-level layer. Prior authorization is filled with checkboxes, so a work that moves forward becomes the closest reward the queue can measure. That means a denial can still produce progress in the only currency. The system tracks a new submission, a new re-review, a new state. Reward prediction error fits this pressure. A new status update after a denial is often better than the brain predicted, so attention snaps back to the same behavior. When the queue provides tiny chances, the learning system treats each one like proof that effort matters. Schultz, Dayan, and Montague's work ties reward learning to expectation, not to the reward itself. In their experiments, a queue that predicts food starts by triggering dopamine activity, then shifts that activity from the food to the queue once the animal learns the link. Track how your brain reacts when a loading queue finally flips to success. That flip is an update to expectation. If the outcome arrives sooner or more reliably than predicted, dopamine signals a better than expected reward. If it disappoints, dopamine signals a worse than expected reward. Now map that onto coverage decisions. The prior authorization workflow creates queues such as authorization pending, additional information requested, or appeal under review. Those queues are not the final outcome, but they still produce prediction errors. When the queue treats a missing document instead of a dead end, the next branch can look like a better result than before. The brain then reweights the behavior that led to the branch, which means compulsive checking can grow even when the overall approval rate does not.